Hello, I'm Paul Brown, and I'd like to tell you about the Diagram Widget, a mechanism for adding interactive diagram editing capabilities to cross-platform applications built with the Fyne toolkit. The widget is an extension of work begun by Charles Daniels a while back. Applications incorporating interactive diagrams are typically managing some kind of underlying information, some of which is displayed in diagrams. In these applications, the relationships between the underlying information and the graphical elements of the diagram tend to be non-trivial. We will start by taking a look at the architecture of this type of application and an example application that illustrates some of the complexities involved. We will then examine the diagram widget itself, highlighting and demonstrating its features. We will conclude with a brief look at the provisions for extending the behavior of the widget and its nodes and links. Applications employing interactive diagrams typically manage an underlying set of information, such as a model of a design. Different views of the information are presented, through which the information may be both viewed and edited. For example, a graphical interactive development environment, or IDE, may present a hierarchical view of the design, one or more diagram views of the design, and the attributes or properties of a selected design element. To better understand the mapping complexities, let's take a look at an actual application. Here we have an IDE for the Concept Representation Language, a research language exploring a minimalist metamodel for representing designs. The underlying model is implemented in Go, and the entire application is built with the Fyne toolkit. The IDE presents three views of the design: a tree view of the entire model in the upper left, one or more diagram views on the right, and an attributes or properties view of selected model elements in the lower left. The diagram elements comprise nodes and links, each of which is a view of some aspect of the model. The diagram nodes have a fairly straightforward connection to the underlying model. Each represents one of the concepts of the diagram in the model. The links, on the other hand, have a more complex relationship. Consider the ownership of the model element by the model. In the tree view, this relationship manifests as a parent-child relationship between the tree nodes. The properties view shows the relationship as simply a pointer that the model element has to its owner. In the diagram, the relationship is a graphical object connecting the model element to the model. So let's try this in more detail. I have the ownership relation here selected. If I drag it to another object, notice the perimeter highlights in green saying the connection is allowed. And now I look at the tree, I can see that the model element is no longer a child of the model. But if I open up this class here that's the diagram view, then lo and behold, the model element is now a child of the diagram view. So by moving the end of the graphical object to a different object, I've changed the ownership relation in the underlying model. And of course, if I put it back, then it is now, once again, a child of the model, which is where it belongs. Other things we can do is edit information wherever it appears. So we've called this a model element here. I can actually edit the name of the model element. And if I select that model element, we notice that the name is also now appearing, the edited name is now appearing down in the label here. And if I change it back here, the diagram updates automatically. And of course, it's changed in the tree view as well. So we get the edit anywhere capability. At the moment, I haven't got the editing turned on for the tree view up here, but that's a straightforward fine widget exercise here. Now let's look at some other things that we can do. Any place in our model here that we find a diagram, so I've got another domain here I call the house domain, and I have a diagram indicated by the D here. Then I can show the diagram, and this is actually another diagram widget appearing over here. I'll create a concept called, let's call it a house. And I'm going to create another concept over here called a kitchen. And if I look at my model on the left here, in my house domain, I now have a house and a kitchen. If I want to establish an ownership relation there, then I can take this element off of the taskbar. And what we've just done here, this is a taskbar. We created an element by selecting an element off the taskbar, clicking in the diagram, and creating it. Now we're going to create a link between them, and this is an ownership link. And if I move the mouse over this object, it highlights indicating this is an acceptable starting point for this link. I can now click the mouse, drag up to the other object, and notice it's highlighted in green now, indicating that it is an acceptable target for the other end of the link. If I let go, we now have not only have the graphical link established here, but if I look back in my tree, I have to open up the house, and I can now see that the kitchen is the child of a house. Now there's another kind of concept that illustrates some of the capabilities of these link relationships. Ownership, any object can own any object in the model that I've got here. Well, there's a particular kind of object that's called a reference. And there is a kind of link that indicates the kind of object that the reference points to. And so if I select that, and I move my cursor over these other objects, notice they're not highlighting, but if I move them over to a reference, the reference is highlighted, which tells us that we can start that kind of pointer from this kind of object. And I'll click, and then I'll drag over here, and any kind of object can be the target of that, including another link. So if I notice here, see the red X, or the green X that highlights in the middle. If I let go, I'm now making a reference to the ownership pointer between these two objects. And as I did before, I could take that end and say, oh, this is now a reference to a house, or this is a reference to a kitchen. So some other things we can do here, if we go over to the house domain, let's add to that another diagram. So we'll call this an alternate view. And notice there are no concepts in there to begin with, but we can get them in there simply by dragging them over from the tree. So let's grab the house, and we'll drag it over into the diagram, and lo and behold, we have the house. If I edit it here, if I change the name of the house, let's call it house X. I go back to the other diagram, notice it's house X here, and again, if it's selected, I can select it here. It's down in the properties view as well, and I can put the name back. Other interesting things that we can do, I've got a context menu here, and one of the things I can do is show owned concepts. And as we said before, we had made the kitchen a child of the house. So if I show the owned concepts, lo and behold, the kitchen shows up over here. And I can take this reference that we had in the other diagram, and I can drag it into this diagram as well. And then I can use its context menu to say, show me the referenced concept. And lo and behold, we get that arrow there. Now these are simply views. Even though I've got all the classes displayed here, I can go here and I can delete the concept view, and I remove the picture of the reference here, but it's still in the model and it's still present in the other diagram. So now let's take a more detailed look at the diagram widget itself and its capabilities. So there's more to the structure of the diagram widget than meets the eye. The diagram widget itself is the widget that is directly incorporated into the fyne application. Under the covers, the diagram widget has a scroll container, and that scroll container is the parent of a drawing area, which is where the diagram elements actually appear. Now the diagram elements themselves come in two flavors. We have diagram nodes and we have diagram links. From an application perspective, these are being added to the diagram widget, so the application is not really aware of the intervening classes there. Now a diagram node can contain any canvas object, from a simple piece of text to a full-blown hierarchy of widgets. Diagram links can be adorned with graphical decorations, anchored texts, elements in there that can be little floating labels along the link, and decorations that provide a way to have arrows and other kinds of adornments on the links. Now links can connect to any diagram element, whether it's a node or another link. These connections are made via graphical areas that are referred to as connection pads. There's a default connection pad on each graphical element. For a node, this is a rectangular region around the periphery of the node. For a link, it is a point in the midpoint of the link line. The diagram widget itself manages all the user interactions involved in actually making these connections, and an application supplied callback determines which link pad connections are allowed. The default allows any connection, and let's play with it a bit. So here we have the diagram widget demo that's included in the fyne-x release. Notice that we have different kinds of nodes here in terms of content. This node has simple text in it. This node has a button. This node down here actually has a collection of buttons in a container. And so you can put whatever you want inside nodes. That's completely up to the application itself. Now nodes can be dragged around and resized. Notice that as we drag it around, the links are all maintaining their connections. If I select the node, I get corner boxes, and we can resize them. The minimum size of the node is determined by the minimum size of the content that you put in the node here. Links connect to nodes and to other links. So here's a link. This link right here is connected on one end to a node and the other end to a link. The connectivity of links is managed by the diagram widget itself. So if I select a link, I can grab an end and I can drag it to another node. So notice the nodes are highlighting in green, indicating that a connection to that node is allowed. The connectivity is determined by a callback provided by the application that determines which nodes or which diagram elements are acceptable endpoint connections for this particular link. And you can have different kinds of links. So not only can we connect to the nodes, we can also connect to other links. So I just connected this one over here, and notice if I move, oops, sorry, move this node here, that the link remains connected to the other link. And I can put the end back where it was originally. Now, links have graphical annotations on them, and in this case here in the red link, link 1, we've got 2 arrows back to back at this end, another 2 arrows at this end. So we can put multiple decorations at 3 reference points on the links, either end or in the midpoint. And on link 1 here, I've got a pair of arrows at each location. The decorations can be polygons as well. So here's a triangle polygon placed at the midpoint on link 3. Now, another feature of links is that we can have floating text annotations. Here I have a label link 1. Now, I say floating text. You can move the text around, but the relative position of the text to its anchor point on the line remains fixed as the link moves around. So notice I'm moving, the link is moving left to right, so is the link 1 annotation along with it. Now, there are 3 reference points that you can attach these floating text to, the 2 endpoints of the link and the midpoint. And so here we have the source role annotation is connected to this endpoint. And again, as I move the node around, we see that the floating text remains anchored there. Typically, the labels or the floating text at the ends are used to indicate either the role that the node plays with respect to the other node, or in other cases, we can put multiplicity annotations on there, 0 or more. You can have multiple floating text or multiple anchored text annotations at each end. So I could put at this end both a multiplicity text and a role name. So there's a lot of flexibility there as well. Let's see. So as I said, we can put anything we want in here, buttons in particular. In the demo application, there is a simple layout algorithm that iterates using a spring algorithm. And this button here is connected to do one iteration of that algorithm. So if I click on it, we get movement of the nodes. This button here is connected to run the algorithm to completion. So I click on that and we get a spring-based layout in there. Now notice when I did the layout, node 5 kind of went off the edge of the page and we got automatic scrolling. So that's the scroll bar, scroll container that I mentioned earlier. And as we move things around, I can move, then the scroll bars will extend to cover the contents that's there. So a number of callbacks are provided to integrate the diagram widget into the application. We've already mentioned the isConnectionAllowed callback that determines the paths to which a given link end may connect. The link connection changed callback informs the application of connectivity changes. We saw this earlier when the ownership link changes were reflected in the model. In the earlier example, the mouse up callback was used to complete the drag and drop action from the tree to the diagram, and the on-tapped callback was used to implement the diagram changes based on a toolbar selection and a click in the drawing area. Finally, the nodes and links may be customized by the application. All diagram elements have configurable set of graphic properties. The IDE example uses these to color some of the nodes, and the diagram widget demo uses them to color one of the links. Nodes and links are extensible in the same sense that other Fyne widgets are, but the initialization of these extensions is slightly different. This is because the relationship between the diagram element and the diagram widget itself must be initialized to enable the diagram widget to properly manage the diagram elements. So we've seen that the diagram widget can provide an interactive diagram capability to cross-platform applications. The messy graphical manipulations are all handled by the widget, leaving the application designer free to focus on application-level behavior. Callbacks provide the hooks to coordinate changes to the diagram with application behavior. It's easy to customize both the appearance and the behavior of the diagram elements. There's several useful links here. There's a link to a quick overview of the diagram widget on a YouTube video. There's a link to the example IDE application that we've been looking at. And finally, a link to the fyne-x extensions themselves that contains the diagram widget. And I'd like to close with a thank you to Charles Daniels, who got this work off the ground.